Now, in this video, we are going to be looking at the relation between the sector of a circle and the surface of a cone. Now, I hope you've not forgotten how a sector of a circle looks like. So if we've got this sector of a circle, so let's say we've got this. Now let's name this. So this is the center. Now let's say this A. Let's call this middle X and call this B. Now this is the angle. Let's call it theta. And let's call the radius L. So we've got L. Does this make sense? Now this is a sector of a circle. Now if we decide to hold the edges A and B, so you hold the edges A and B, and then you try to fold it so that A and B touches each other, and so that you have something that looks like a funnel. Basically, it's like a cone. So you take A and B, those edges, and you fold it until you get a cone. So we should be having something like this. So we should have something like this. Does this make sense? Now if you look, this is the L, the radius of the sector L, and then we would have the radius of this circular base. I'll come to that later. We have our height. Does this make sense? Now if I turn it upside down, this cone would now look something like this. Let's have it somewhere here. So if I turn it, it's going to look like this. So let's make it upright so that you can really understand this. So we have something like this. So remember this, our L. And then we've got our radius. Now if you look, because we picked A and B and then we joined it together, this place here would be AB. Because AB met. Does that make sense? Then I should be having X here. This part here. It becomes this, and L. Now look closely. Now remember, we said that area of any shape is the space the shape takes up. It means that the area of this sector is this part. Now when I fold this sector to become a cone, this place I shaded, if I want to represent it on the cone, is this part. Can you see? So it then means that if you look closely, the area of this sector is the, what do we call this part I just shaded in a cone? The curved surface area. So the area of a sector is equal to the curved surface area of the cone. Now don't forget this. When a sector is folded to become a cone, the area of the sector, this part, becomes the curved surface area of the cone. Now remember, I always tell you, you don't need to cram this thing. All you need to do is to draw it, and then you are going to see it. This part here, the area of the sector, is the same thing as this part of the cone, which is known as the curved surface area of the cone. Now there is one more relation. Now remember, this part of a circle, this part here, is called an arc. So the arc is what formed this part of the cone. Now when we folded the sector up, this part here that is just like kind of flat is what became the circular base of the cone. Does that make sense? The arc here became the circular base of the cone. Does that make sense? So we can have another relation. The length of arc equals to, now what's the circular base of a cone? What is this circular base? It's called the circumference. So we have the circumference of the circular base of the cone. Does this make sense? Now, don't forget this part here, which is the space the sector takes and is known as the area of the sector, is the same as this part here, which is known as the curved surface area of the cone. Also, this part here, which is known as the length of arc, is the same thing as this part here. It's what becomes this part here, which is known as the circumference of the circular base of the cone. I hope you understand. So this relation here is very important. Does that make sense? Now let's clean somewhere up here and let me show you this in formula form. So we have area of sector equals to curved surface area of the cone. Now if I ask you what is the formula for the area of this sector, remember the sector is just a fraction of the area of a circle. So I should be having theta over 360 times pi. Now instead of r, the radius is L here. So I'll be saying pi L square. Does that make sense? Remember before we used to use pi r square, and r represent the radius of the circle in which the sector was gotten from. But in this case, the radius is L. So I have theta over 360 times pi L square equals to, what's the formula for the curved surface area of the cone? I think we know it as pi RL. Does this make sense? Now let's take the second part. Length of arc. Remember, length of arc is just a fraction of the circumference of a circle. So we should have it as theta over 360 times. Remember before it used to be 2 pi r. But in this case, because our radius is L, we'll have it as 2 pi L. Does that make sense? Equals to circumference of the circular base of the cone. Now what's the formula for the circumference of a circle? 2 pi r share. So in this case our r is r, so we have it as 2 pi r. Does that make sense? So this is like a formula relation of what we have in this place. Now I believe that an example will make it simpler, so let's take an example.